Well, we're marching through factoring, and now we're going to look at a factoring technique of perfect squares and the difference of squares. And this is example 3 in your textbook on page 239. And so we first have this function equation, this quadratic equation, 4x squared minus 12x plus 9. And when we're talking about perfect squares, we're looking at the quadratic term, the lead term, and specifically we're looking at this lead coefficient, which is 4, which is a perfect square. 2 times 2 is 4. And our constant term, this positive 9, is also a perfect square. 3 times 3 equals 9. And another thing to consider here is I've got a positive constant and I've got a negative middle term or linear term. Now, since they're perfect squares, I can set up my factoring as such as this. I can take this the square root of 4, and so we've got 2x, because the x squared is also a perfect square. And since this is positive and this is negative, inside my parentheses, I'm going to have a negative negative. Let me go ahead and put the 2x over here as well. So I've got 2x, 2x, and then I got a negative negative inside my parentheses. And I take the square root of 9, that 3, and this is what I'm going to complete this perfect square. And so my two factors are 2x minus 3. 2x minus 3, and if I wanted to FOIL that back to make sure that this actually does equal before I set each of these factors equal to 0, well, 2x times 2x is 4x squared, and 2x times negative 3 is negative 6x, and negative 3 times 2x is negative 6x. And then negative 3 times negative 3 is positive 9. And when we combine the like terms, we see that we FOIL this back, we come back to our original quadratic equation of 4x squared minus 12x plus 9. Now, I've got to set this factor equal to 0. And I'm just going to do one of them because I got it twice, which means that this is going to have one solution. So I got 2x minus 3 equals 0. We're going to add 3 to both sides, so we got 2x equals 3. And now we're going to divide by 2, and so x is equal to 3 over 2. And that is our solution. We have 1 root 1 0, 3 over 2. Now let's go look at another one, and I think this one, yes, this one is a difference of squares, but we'll have a greatest common factor, so we got both. So I got 81x squared minus 9x. Now, my 81 is a perfect square, 9 times 9, and of course the x squared is a perfect square, and the negative 9 is a perfect square, 3 times 3. But both 81 and negative 9 are divisible by 9, and I got an x squared and an x in this equation, so I can factor out greatest common factor 9x. So we got 9x, and that leaves us with 9x minus 1. And those are our two factors. This didn't really illustrate the difference of squares like I would have done if I was making up this problem. It's really more of a greatest common factor problem. But we're going to set each of the factors equal to 0. So we got 9x equals 0. We divide by 9, and of course 0 divided by 9 is of course just 0. And then we got 9x minus 1. 9x minus 1 is our second factor. They both are actually perfect squares, but I don't have variable in both terms anymore since I factored out the greatest common factor. And we set that equal to 0. And let's see here. Then we've got, we add 1 to both sides, so we got 9x equals 1. We divide both sides by 9. And our second solution is 1/9. And so our two solutions in this are 0 and 1/9. And then this again, I don't know why this would be in the set of perfect squares and difference of squares. This is really just the greatest common factor problem, kind of like the other one was. We'll probably look at some difference of squares in class because these were not very good examples that we had here in this set in the book. But I got 6a squared minus 3a. Well, both 6 and 3 are divisible by 3. That's the greatest common factor. And I've got an a squared and an a. So I'm just going to factor out the greatest common factor of 3a. And then that's going to leave me with 2a minus 1. And again, I'm going to set both of these factors equal to 0. And let's see, over here at 0 divided by 3, of course, is just going to give me 0 for one of my factors. And then I've got 2a minus 1 equals 0. We're going to add 1 to both sides, giving us 2a equals 1. And we divide by 2, and a is equal to 1/2. And my two factors in this binomial are 0 and 1/2. Okay, like I say, we had the first one did give us a perfect square. We didn't really see a true difference of squares in what we have here. They were really more of a greatest common factor problem. But hey, maybe we'll run into it a little bit later. Well, in fact, not maybe. I know we will.